do one more application of transistor mirror circuits. Mirror circuit means if you connect, you have a transistor. Okay. So you have a two or more transistor, and if you connect their bases, say you say this is ground, this is ground, and here if you say this is my collector, this is collector pin, this is the emitter pin, and this is a base pin. And if I now connect a single power supply here, say in the middle, say this is plus VCC, this is R. Now this is called mirror circuit. What do you mean by mirror circuit? Now each, if the bases are connected, now say there are two transistors T1 and T2. Their current gain is beta 1 and beta 2. Okay. So if I say both the transistor T1, T2 are identical, if both transistor T1 and T2 are identical, well, all in the all respect, then what I can say, I can say with surety that beta 1 is equal to beta 2 equals to beta, and base emitter voltage, both will have a same base emitter voltage almost equal. Okay, VB1 will be equal to VB2 and this will be equal to VBE. Now say a current is coming IR, a reference current is coming here. Reference current is coming here. Now this current will divide in three parts. Okay, one is going here, that will say this transistor 1, so we'll call this is IC1. Okay, and now current will go here, this is IB1 and this is your IB2. This is same node. Okay, and current is dividing as a IB1 and IB2. So I can say my I reference current IR is equal to IB1 plus IB2 plus IC1 plus IC1. Now I'm saying that both these transistors are identical. So both when both are transistors are identical, then they will have a same. If both transistors are identical, then they have a beta equal to beta 2, VB1 equals to VB, both are same. So suppose some point is there. Now for this point, this VB is same, this VB is same. Okay. So for this point, this circuit is same. If I come from here to here or here to here, both circuits are same. That means now for both the circuits, VB is same, is both the circuits, your IB also same. So when I say beta 1 is equal to beta 2, VB is equal to VB2, this makes sure that IB1 is also equal to IB2, both are identical. Okay, and same base voltage is applied. Same base voltage is there, same drop is there, so same IB is there. So I can write IB is also equal to IB1 is equal to IB2 is equal to IB. And when beta is same, IB is same, you can say with surety IC1 equal to IC2 equal to IC. So this equation now can be written as a IR equal to IB2 IB plus IC. Now if the current is here going IC1, okay, here current is going IC2, both the current will be same if the transistors are identical. That means now here it is open, but generally this is connected with this one, but we don't show this connection because there are n number of transistors. Okay, so if you want, you have 100 transistor, and all the transistor, if you want to flow same current, okay, you want this all the transistors should behave like a mirror to each other. So then you should connect their bases. The transistors should be identical, and if you connect this bases and you connect the circuit this way, all will have a same current. Now this is your, and now this is the reference current, This is IB, this is IC. Now you know this is IC is beta IB. This is 2IB plus beta IB. So now if I take IB common, this will give me beta plus 2IB IR, and from here I can find what is the value of IB. That will be I reference upon beta plus 2. And if I want to find the IC, that will be beta IB, and IB is IR upon beta plus 1, 2. So IB is your beta IR beta plus 2. And if I solve now, my IC will be almost equal to I reference, because beta is greater than 1. So I can neglect this 2. So and beta will cancel. So if there are n number of transistor, each transistor will have a same collector current is flowing, which will be almost equal to the reference current. Reference current means the current flowing in this resistors. This is called your mirror circuit. Okay. So now if you have doubt, you can ask me. So I'm saying this both transistors are identical. Okay. And now if you apply same transistor means both have a same gain. Now if you are applying same base voltage, they will have a same IB. If they have same IB, that means they will have same IC. So same IC will flow. And now from applying this circuit, I can calculate what is the value of I reference. Okay. Now you have these relations, and now you have to find what is the value of I reference. So how to find the I reference now? So for I reference, you can choose either this path or you can choose this path. Okay. So I can write minus VCC plus I reference into R, and now plus VB equals to 0. So my I reference will be VCC minus VB upon R. This is my I reference value, and this current will be flowing in each collector, each inside the each transistor. Okay, that is your mirror circuit. Now let us understand with some examples. So I'm erasing this one. Have you any question? Karishma, is that point is clear?
Yes, sir.
So let me demonstrate this method or this circuit with some examples. Three times this question appear in the exam, 2 times in the gate, 1 time in the jam, 1 time in the CSIR network, 4 times. Okay. So say you have this a battery here. You have base, you have 2 transistors, both are grounded. Okay, and this is your reference, this is directly going there, and these bases are connected. You can connect this base directly. I'm just drawing a little bit upper side. This base, these bases are connected. Okay, and the resistor value is 100 ohm, and this is your 5-volt battery. Beta value for the question is given. Beta is not value is not given. They say beta is very high. Beta is very high, and VB is given 0.7 volt in this question. Okay. Now what they're asking to calculate us, they're asking find a collector current in each transistor. Transistors are identical. Okay. Transistors are identical. It is given. transistors are identical, means if their VB is given same, then they become identical. Identical if you are applying same base voltage to them. Now I say this current is coming I, this is IR, here IC2. Okay, this current is coming, here current is going IB1, here current is going IB2, and here a current is going IC2. Now again, because transistors are identical, so you can say IB1 is equal to IB2, okay, equal to IB, and IC1 is equal to IC2 is equal to IC. And now you can write the current division, you can apply current division this point. So my I reference is 2IB plus IC1 or IC. And from now I can find, so IR is basically beta plus 2IB, and IB and IC is beta IR beta plus 2. This is the value. IC just now formula we have already derived. And now if beta is greater than 1, so I can say my IC is equal to almost IR for this given question. And now you can find, you want to find the IC, you find the IR. And IR can be calculated. Just now I told you, you come from minus VCC to either this way or you go this way. So VCC minus VB upon R, that is 5 volt minus 0.7 volt divided by 100, that is 4.3 divided by 100, that is 0.043 ampere or 43 milliamps. 43 milliamperes. That is the current value. Yoshita, any question?
Yes, sir.
Any question? Or it's clear?
No, sir. Yes, sir,
Okay.
it's clear.
Okay. Now, instead of 2, there may be 3 also. Let us do one question from 3 transistors. There can be 100 transistors connected in such a manner. Method remains the same. There will be nothing new thing. Let us do connect now 3 transistors. So here I am putting one transistor with a resistor plus VCC, and remainings are nothing. Okay, remainings are directly connected. Say 2 base, say this is transistor, and say this is one more transistor. Connect this one here, you connect this one here, this is ground, this is ground, ground. Here IE is coming. Okay, IE, IE. Here IC is coming, here IC is coming. And this point you can connect here. So this I reference is coming. Okay. Now I reference here IB1 is going, here IB2 is going, and here IB3 is going. And now ties are identical. So you can say IB1 is equal to IB2 equal to IB3. Similarly, IC1 is equal to IC2 is equal to IC3 is equal to IB, and this is equal to IC. And this such thing is same. The IR will be equal to IC, IC. So IR now this time will be equal to IC going down plus IB1, IB2, IB3 plus 3IB plus 3IB, and IR will be beta plus 3IB, and IB will be IR upon beta plus 3, IC will be beta IR beta plus 3. Now say if say beta is 100 given, then you can put the value. So this is value, and now you're going to find first IR.
सर आई आर इक्वल टू आई सी प्लस 3IB जो लिखा है वो कैसे हुआ, थोड़ा एक्सप्लेन कर दीजिए।
ये IR आ रहा है, इधर करंट IR आ रहा है,
यस सर।
और यहाँ से ये IC इसमें जा रहा है,
हाँ।
और सम करंट यहाँ, ये समझ ये कुछ करंट यहाँ पे आ रहा है, से ये I आ रहा है, और या इक्वल टू कितना है IB1, IB2, IB3।
IB3।
सो IR इक्वल टू IC, IB1, IB2, IB3।
ओके, गॉट इट।
ओके, इसको टोटल को बोल दो IB, IB1, IB2, IB3। So IR again will be BCC, come here, this circuit, and go here and go by this, or you can go like this. You have to complete the circuit. Come here, go by like this. Okay, so VCC minus VB upon R. R value is given 1.2 kilo ohm. R is 1.2 kilo ohm. VCC value is given 6 volt. So 6 minus 0.7, VB is 0.7, and then you have R value 1.2 kilo ohm. Tell me the reference value, current value.
$4.41.
4.41 or 4.42, okay, whatever. So 4 point, I like 4.42 or 4.41 milliampere, let us say. And IC value will be now, IC formula is this one. So
4.29 milliamp.
4.29 milliampere. So IC will be now beta is 100 into 4.41 milliamps. IC upon 103. If you solve this one, this will come 4.29 milliamp.
सर हम लोग वो जो साइट के जो कनेक्शन दिए हैं, ये
हाँ,
साइट के कनेक्शन क्यों यूज किए हैं, मतलब
ये एक्चुअली ये ऐसे तो ओपन तो होते नहीं है, ये VCC से कनेक्टेड होता है यहाँ से डायरेक्टली।
नहीं सर, ये वाला नहीं, वो आर के नीचे से जो कनेक्शन जा रहा है, आईबी जहां से पास कर रहा है,
ये वाला,
ये वाला। हाँ।
हाँ, तो ये बेस से कनेक्ट किया है, इस पॉइंट को बेस से कनेक्ट किया है।
अच्छा
तो
अच्छा।
वरना बेस पे बाइसिंग कैसे आएगा? यहाँ से बेस पे तो बाइसिंग चाहिए ना,
ओ
VB।
हाँ, गॉट इट सर, गॉट इट।
यहाँ से ये तो VB चाहिए ना।
राइट
अब
राइट।
ये पॉइंट तो सपोज VB है, VB। अब इसके लिए भी सेम VB है, इसके लिए भी सेम VB है, इसके लिए भी सेम VB है।
ओके।
ओके, सेम
हाँ
VB है, इसलिए VB ड्रॉप भी सेम ही है, IB भी सेम ही है। Now let us do some exam problems, and then we'll start AC amplifier. Some problem came in exam. Let us solve those problems. So gate 24. Okay, this is the problem. Transistor operating in cutoff region. Transistor operating in cutoff region. Okay, so they have given you a transistor. Now you have to tell me how to do operation region. You know how to find out. 12 volt, 2.2 kilo ohm. Here I am measuring V naught. This is grounded. Here a resistance is coming, and here a minus 12 volt is there. Minus 12 volt plus 1 volt. Okay. Now tell me what is V naught. This says the value of common emitter gain beta. Beta is 100 for this transistor. Beta is transistor, and ignore reverse saturation current. Ignore reverse saturation current. Ignore reverse saturation current and find out the V naught. Tell me how to find out V naught. And the values of R resistances are given 15 kilo ohm and 100 kilo ohm. 15 kilo ohm and 100 kilo ohm. Now look at the circuit. Tell me how can we solve this circuit? What is the value of V? So if this transistor, the first thing is if transistor has to operate in the active region, VB should be positive or negative for this transistor NPN. VB should be positive or negative. If I say this is my VP, so if I want to flow
Negative.
IB, if I want to flow IB, VB should be negative or positive?
Negative.
Why? If it is negative, then how VB with 0.7 you will apply? This is basically a diode, na? Suppose this is a PN diode. Now you want to conduct this one, so you will apply positive voltage or negative voltage. This voltage should be positive or negative.
Positive.
Then only it will cut off, na? Then only it will flow the current like this.
Got it, sir.
Okay, so this VB should be positive. Now here VB value is positive or negative. Find out nodal analysis. Make it open. Say this is open. I want to find what is VB here. Then open circuit voltage here, and then I will connect this transistor. Okay, tell me what is VB. So current is coming, say here, and current is going here. Current is going, say negative is there. So say current is coming from here, current is going here. So say this is I1, say this is I2. Now I1 is equal to I2. Okay, 1 minus VB upon 15 kilo ohm is equal to VB minus plus 12. Nodal, I'm applying nodal analysis. Nodal analysis. VB plus 2, 12 upon equal to 100 kilo ohm. Tell me what is the VB value after solving this one. VB coming positive or negative? So 100 minus 100 VB equal to 15 VB plus 15 to 12. Solve this equation and tell me what is the VB value. So VB will come how much? Say 115 VB is equal to 100 minus how much? Tell me. 15 into 12.
180.
180. So this is VB is equal to
Minus
minus
80 upon 115.
15. So this is the negative value. Okay. So base is negative. And you know, if you want to flow the IS, for NPN transistor, base should be positive. Then only you can flow IB. That means now if you connect here, what will be the IB value? What is the IB value now? 0. Why? Because it requires 0.7 volt. We are making more reverse bias. Okay, in order to conduct this one, VB should be 0.7. Okay, in order so in order that in order PN junction to conduct a positive VB is required in this NPN transistor. Okay. So now IB will not flow. If IB is 0, then what is the value of IB? If IB is 0, what is the value of IC? Tell me.
Sir, IC will be 0.
Yes. So why IC is what?
Beta
IC
IB.
is beta IB plus ICO. This we generally take the reverse saturation current. This we generally take 0. And the question itself says reverse saturation current is 0. So my IB 0, so 0 plus 0, even microampere IC will not flow. Okay. Because of this one, reverse bias also it will not flow any reverse saturation current. Because time says you're applying minus. You're applying this is the base, and now you're applying minus. So there will be a reverse current that is also not flowing. Okay. So this will be IC will be 0. Here also it is 0. So if IC is 0, then what is the value of V naught? Tell me. If IC is 0, what is the value of V naught?
12 volts.
12 volt. So V0 will become 12 volt because there is a no drop. So this voltage will come directly here. Okay. And when we were discussing my IV characteristics of transistor IC versus VC, that time I told you na, this is my curve, this is high resistance, and if my VCE becomes VCC, okay, so here this is what, this is VCE, VCE become equal to VCC, so this is V naught is what, VCE, here is 0, so VC is equal to VCC, which is 12 volt. So this region is cutoff region. Whenever your point is here, you're cut off. Whenever VC is close to 0, you are in saturation. Okay. So this is the operation of example. So now whenever you question in the exam asks whether this transistor is the cutoff active or active or saturation, you always check this one. What is VB? If VB is negative, current is this will not forward bias, so IB will automatically become 0, and you will come directly to cutoff region. Okay. And now if VC is 0, then you are in saturation. If VC is not 0 and IC is also flowing, okay. If VC is 0, then IC will be equal to IC saturation. That will be also your saturation. Okay. Saturation. Then you can solve this one. Okay. 1 minute. Tell me, is there any question? Akansha, Sally, is that point clear?
Yes, sir.
Okay. So now this we have seen active region, we have seen cutoff region, and now I'll solve one question for saturation region. Suppose now operation in saturation region. How to find saturation region? Already you know how to find saturation region, but I'll solve one problem. Operation in saturation. Okay. So say you have a transistor. Here is plus 9 volt. This is given 6.8 kilo ohm. This is your grounded. And this is 15 kilo ohm given. And this is your V input. Here IB is flowing, and here IC is flowing. Okay. So question says that this transistor is working in the what is the value of V input? Find the value of V input. Beta is given 25. Okay. Now says find the value of V input. What is the value of V input? So that this will start conducting. What is the value of V input? So that transistor operates in saturation region. What is the value of V input? Now this everything depends on V input. If V input is very high, obviously this current will become IB current will become very high. If IB become very high, and then beta into IB, IC can become greater than IC saturation. So everything depends on V input. So there's a minimum value of V input which will drive this transistor into the saturation region. That value we have to calculate. Okay, find the value of V naught so that the transistor operates in saturation region. Okay, minimum value. Find the minimum value. Minimum value of VI. Minimum value of VI. And now, whenever transistor is in the saturation region, you know VC is close to 0. So VC also given in the question. VC is 0.2 volt given. Then it should be 0 or it's close to 0. It will be given. If it's not given, you can take 0. If it's given something 0.2, 0.3, whatever. Even some standard books always take VC 0.2 volt. Okay. So you can take this value, and now you have to find the minimum value VI. So let us find out how to find out. Tell me. So first of all, VC is given to you. That is a great thing. And IC saturation also should be given. Let me check. IC saturation is not given. Okay. Now let us find the VC is given. Okay. And we know the equation for VC is what? VC is equal to VCC minus IC RC. VCC given, RC is given, VC is given, and now VC is in saturation, so this current will be IC saturation. This current will be IC saturation because transistor is operating in saturation. Is already given. Okay, transistor in saturation. Transistor is in saturation. Now put the value, find the value of IC saturation. So IC saturation will be how much? Tell me. VCC minus VCE upon RC. VCC is 9 volt. VCE is minus 0.2 volt. What is the value of IC? 6.8 kilo ohm. Tell me what is the value?
Sir, 1.41 milliampere.
1.14 or 1.294. How much?
So
Whatever.
1.29.
1.29. Okay. Whatever you check it. 1.294 milliamps. Okay. Now let us. Now you have IC saturation. This current is flowing in the circuit this time. So you can find the value. You can do back calculation. You can find the beta minimum IB value. Okay. So just note down this one. And now you can find the IB minimum. Whenever there is a current. So now this is, we are taking minimum current. Okay, IB is beta IB. That may be greater than this one, but that greater current we are not taking. We are taking the minimum current for saturation. Okay, so this will be now your IB minimum. Because if current is greater than this one, IB minimum, then this current will go above IC. Okay, this go negative. So I'm taking minimum value IB1. Minimum value IB will be what? IC saturation upon beta. So IC saturation value is 1.294 milliamp and beta value is given 25. Okay, so you can find the value of IB minimum flowing in the circuit. Tell me what is the value of IB minimum? What is the value?
So 0.05.
0.0516. Okay, 0.05176. कितना है जो भी है
Yes,
So
sir.
516.
Yes, sir. 176.
516 or 5516.
Sir, correct है.
Correct. ठीक है. अब you know the value of IB. Okay. So this is so for saturation. Your current should be greater than this one. Okay, this is a minimum value. This IB will make draw transistor in the saturation region. Okay. So now I can say my IB should be greater than this IB minimum. Greater than equal to, then only transistor will come saturation. And now IB will be how much? If I take this is 0.7 volt, IB will be, tell me, IB will be V input minus V 0.7 volt divided by 15 kilo ohm is the value of IB. And now this should be greater than equal to IB minimum, which is 0.0516 milliamps. Okay, now solve this one. So VI minus 0.7 greater than equal to milliampere will cancel out. So 15 into 0.0156. And so VI should be greater than equal to, tell me how much coming? 15 into 0.0516 plus 0.7 volt. So VI will come greater than equal to, tell me the value now.
Sir, 1.474.
1.47, 1.48 I'm taking, okay? So this is the 1.48 volts. This is the answer. Okay, so have you understood the problem now? How to do problem of saturation and how to do problems of cutoff and active results, okay? So I've done all three type of examples. Generally, these questions only come in exam. Okay. Now we'll go to the next. हाँ.
सर हम लोग कभी कभी ये जो एमीटर के साइड में जो कनेक्शन है वहां पे रेजिस्टेंस देते हैं,
हाँ
कभी कभी रेजिस्टेंस नहीं देते हैं, ये
हाँ
दोनों का बीच में डिफरेंस क्या है?
नहीं, वो रजिस्टेंस
देने और
देंगे, रजिस्टर देंगे तो फिर वीसी वो आउटपुट का इक्वेशन चेंज हो जाएगा और क्या। अभी जैसे आपने लिखा ना इक्वेशन, वो इक्वेशन चेंज हो जाएगा। अभी जैसे हमने लिखा वीसी इज इक्वल टू वीसीसी माइनस आईसीआर से लिखा अभी, ठीक है। ये तो अब मैं पहले डिस्कस कर चुका हूँ, अगर ये रजिस्टर नहीं है यहाँ पर तो ये वीसी, ये जो वीसी है, ये वीसी इज इक्वल टू वीसी है। तो बहुत बार डिस्कस कर चुके हैं हम लोग। वीसी, ये जो वोल्टेज है वो दिस वन है। अगर रेजिस्टेंस है तो वीसी अलग होगा, वीसी माइनस वी होगा। दिस इज नाउ वीसी इक्वल टू वीसी माइनस आईसीआरसी, एंड इफ देयर इज a resistance is there, then this will be VCC minus IC RC plus RE। ये इक्वेशन बन जाएगा, बस और क्या, इक्वेशन चेंज हो जाएगा, मीनिंग तो
ओके,
वही है।
गॉट इट सर,
हाँ।
गॉट इट सर।
So let us do some more problem which came in the exam, because I don't want to start new topic today. So at least we see the previous year's problems. Okay. So this is your BCC is given 20.7. This is 5 kilo ohm. This is my RB 500 kilo ohm. Okay, and here some transistors are given, C1, and here you have a resistor which is 1 kilo ohm, and VBE is 0.7 volt, and here also you have a transistor C2. Okay, so question says find the value of IB. Find the IB. Find IB. Tell me how to find IB. So what should I do when I see this circuit? First thing, so what about this? Tell me what about this transistor C1 and this capacitor C1 C2? How to involve or how to solve circuit when capacitors are there? I'm applying DC. So for DC analysis, how to treat capacitor?
Short circuit.
Huh? Shekhar?
Short circuit.
Short circuit. Anyone other? Saraswati?
Sir, it
Sarvanti?
will be open circuit, sir.
Open circuit. So don't bother about a capacitor. Whenever there is a DC and whenever there is a AC, then that time also you don't bother about a capacitor, very high frequency. That time it will be short circuit. Okay, so the impedance of XC is important when only you have a less frequency. Okay, you are greater than 0 and you are not very high frequency. Then only XC will come in the picture. Otherwise, for both the ends, it's a high frequency or DC. DC it is open, high frequency it is short circuit. Okay, so that becomes our life very easy. Okay, so for DC analysis, here only DC for DC analysis. Okay, treat capacitor as an open circuit. Treat capacitors as open circuit, and when it is open circuit, you just for DC it is just open, so I should not bother anything. This is gone. This is gone from here. This is gone from here. Okay, So this question asking IB, this is IB, this is IC. Tell me what is the value of IB now? How to solve IB? Write the equation for IB. In microampere, tell me the value of. So basically now whatever current comes here, this current is IC plus IB. IB is flowing here, IC is flowing down. So I can write minus VCC plus IBRB plus VB equals to VB plus beta plus 1. Here current is what? Beta plus 1 IB. IB into RE equals to 0. So my IB will be what? IB will be VCC minus VB plus RB plus beta plus 1 RE. 20.7 minus 0.7 RB is 500 kilo ohm plus beta plus 1. Beta value you can take. Beta value you can take 500. No, 500, 100 only, 100. 100. Beta value is 100. So 500, 100, 101 into 1 kilo ohm. So this is how much come? 20 upon 601 kilo ohm. And this should come around 20 microampere. Check it, answer is coming or not. Or 33. 33. 33 it will come. Is that clear? Is coming? 33?
Sir.
Okay. Amarpreet,
Yes, sir.
दीपक नहीं है क्या? दीपक
Yes, sir.
आ रहा है ना?
Yes, sir.
ठीक है. Now let us do one more problem. RB 2 kilo ohm. So VCC is given 20 volt. Okay. Beta is given 100. And this is your 1 kilo ohm. Okay. He says VB is 0.7. VCE is 14 volt. VCE 14 volt. Take IC almost equal to IE and find the value of RB. Find the value of RB. So this time output में VC दे रखा है. so that you can find the IC. And once you know the IC, you have beta, you can find the IB. And once you find the IB, you can solve the input equation and you can find the RB. This will be your IB, IC, this is your IE, and this you can take almost equal to IC. And tell me what is the value of RB. So let us solve. First input BC is given. And you know BC is what? BC is your BCC minus IC RC plus RE in this loop. And this is given 14 volt. This is 20. Okay. Then IC is given or not? Question. IC is given 3 milliampere. Huh? Just let me check. No, IC is not given. IC we can find it from here. Huh? IC we can find it from here. So IC, I need to find out. RC is 2 kilo ohm, 1 kilo ohm, that is 3 kilo ohm. 3 kilo ohm. Okay. So my IC will become 20 minus 14 upon 3 kilo ohm. 6 upon 3 kilo ohm. That is 2 milliampere IC. Okay. So my IB will come. IB कितना हो जाएगा?
IC upon beta.
IC upon beta. That is 2 milliamps divided by 100. That is 20 microampere. 5, 20 microampere, 22 into 10 minus 6. That is 20 microamps. Now you can write the input equation. Input equation says my IB is equal to what? IB is equal to VCC minus
VBE
VB upon
RB
RB
into plus beta plus 1 RE.
RE. Okay. Now IB value you have, VCC you have, VB you have, RE you have, beta you have. You can find what is the RB. Instead of beta plus 1 here, because you are taking I to ICCs, you can neglect this 1 also. Okay. You can say beta IB is RE. Beta IB is equal to IE because it is given equal to IC. So you can neglect 1 also. Now solve this one. Solve for RB and tell me what is the value of RB.
865K, sir. 865K.
Just 865 kilo ohm. If you solve this one, RB will come around 865 kilo ohm. Okay, so this was your DC. Okay, let me start something about the AC and tomorrow we'll go in detail. Okay, so I'm erasing this one. The answer will come 865 kilo ohm. You put the values here. Okay. Now let us start with small signal analysis. Small signal analysis. Okay. Now, first of all, you have to understand what is small signal. We have already done for diode also, but let me revise it again. Small signal means what? Okay. So here is small signal means, okay, whenever applied AC amplitude, whenever applied AC amplitude is smaller than thermal voltage, Vt, which is equal to eta kT upon Q. Okay, whenever applied AC amplitude is small than thermal voltage Vt, okay, then we call it, we call it a small signal. Okay, so whenever applied AC amplitude is smaller than the thermal voltage Vt, and Vt value we know 25 millivolt. Okay, so whenever you have a signal which has amplitude is much below Vt, 20 is 1 millivolt, 2 millivolt, 5 millivolt, okay, lesser than thermal voltage, that signal we call that AC signal we call small signal. Okay, now I am solving for this small signal. We cannot apply very high signal for amplification. Okay, why does it so? So say I want to amplify a signal. Let me give you a simplest bias circuit, which is fixed bias circuit first, and we understand why we apply a small signal and why we don't solve this for higher signal. Okay, why this signal is not in volts? Okay, why it is in millivolts only? So let me draw a simplest circuit. Say this is my transistor NPN configuration, and we always in exam questions comes basically on common ammeter, because common ammeter I told you the gain is high, current gain is high, voltage gain is high. So this is only we are I will solve this one mainly for this one, only for your amplification. Now here I am applying V input through a capacitor. AC should come through capacitor, and here for the moment I am making it ground. Say this is ground, and here say a capacitor is C2, and I am measuring V0 here. This is my circuit. So there is a DC, there is a RC value, there is a RB value, there is a power supply. Okay, and here, so whenever circuit is this type, that you are applying AC also along with DC. Okay, so you have to apply superposition principle. Okay, so first step is what is steps? First is, okay, do DC analysis. Do DC analysis and find operating point. Find operating point Q. Because the purpose of DC biasing is only to fix the DC point, and then we'll do amplification. Okay, so say this is my IV, this is my transistor IV characteristics, IC upon VCE. This is different IBs, and when resistance are given, VCC is given, I find my operating point is here, Q. This is my operating point here. Okay. Now this operating point will shift. It will shift or not shift? It will shift if, say, here to here. Now this is my operating point. Here it is my operating point. Fixed by DC supply in active region. Now suppose if I apply AC, so AC also together with DC. Now what will happen? AC will go up and down, positive, negative. So when it's come positive, it comes positive, say when this go positive, okay, this point will shift here. Yes or no? We see it will shift. It will shift its position, na? BC and IC. It will go here. IC will also change. BC will also change because USF. Suppose you are applying 5 volt. Now you are applying some 5 millivolt also. So 5 plus 5 millivolt. Now your voltage point will also. So this point will shift basically. This point will shift here, somewhere here. So BC will also go here. IC will also go here. So we have to check now because this point will go up and down, up and down. This like this. This point will go up and down. These points will go here up and down. So whenever voltage will increase, this point will go up and down, and here you will get the output. So here it will become amplify because this is tilted. So if you draw this one, this small signal will get amplify here because the shift is very high. Because this is a diode, na? Diode. If you change little bit, you change the voltage, the current changes very high. This is your curve. We discuss on diode. Now, if I change small voltage here, this is an exponential current. If I change small here, the change in IC is very high. Small voltage. If your voltage is here, current is here. If your voltage is here, your current is here. So there is a large change in the current. So a small change in the input, there is a large change in the current in the output signal. If you take this signal will become amplified here. Now, if I take this signal itself in the volts, what will happen? This point can go either while it's coming negative. This point can shift either here in the cutoff region, or this point can go here in the saturation region. And I want this point should be in the only active region. Whenever this point is in the active region, that time only you'll get the faithful amplification. If this points go here or this points go here, then the output signal will be distorted. Okay, so that is the purpose we are taking here only a small signal. A small signal will make sure that this your operating point which have been fixed by DC supply should not move away from the active region. Okay, otherwise if you give a large swing of current here, large swing of amplitude here, you will get the large swing in the voltage axis and current axis, and this point will shift. It will go here to here, and anywhere it can go, and that time you will get the amplification, but that amplification will not be faithful. There will be your signal will get distorted. It will go out of range, so it will go distorted. So that's why we always use a small signal. This is the first thing. Okay, now second thing, once you have done the DC analysis, second part, so DC analysis, capacitor will be open. Capacitors will be open. Okay, the second thing is do AC analysis. Okay, while doing AC analysis, what about this DC? Because this is superposition. When I'm using this one, I'm making this 0. When I'm making this one, I'm making the 0. So is doing AC analysis, DC power supply will be turned off. DC power supplies will be turned off. Now DC power supply turned off means if voltage source is there, voltage source will be replaced by short circuit, like we do the network analysis. And current source will be replaced by open circuit. Okay, now what I'm doing, I am going to convert this I want to give you equivalent model of this one. Okay. Now this is my diode. And you know, for AC signals, diode can be replaced by what? A resistor. Okay. And this resistor is called RE. And what is the value of RE? Tell me. What is the value of RE? What is the value of RE? If this is a diode and I am applying DC plus a small AC signal, then what is the value of I told you na, what is the value of resistance? Diode resistance value is what? Amarpreet, what is the value of RE? What is the value of RE? Tell me. किसी को याद ही नहीं है.
Sir, delta V BE upon delta IE.
No. RE model resistance. What is the value of diode? I can replace by superposition principle. We've done the questions. Shekhar, Leo. Small signal analysis of diode.
VT
Karishma.
upon
Huh?
thermal voltage upon
RE is what? RE is eta VT upon current is what? Diode current. How much current is flowing through a diode? Now here, how much current is flowing through the diode? What is this current? IE. So once I know the RE, I can find eta VT upon IE. Eta VT upon IE. Okay. And generally, if you use, generally we take n equal to 1. If I take n equal to 1, so this will be VT upon IE, and VT is room temperature value is 60 millivolt upon IE. If I take eta equals to 1, so this is the value of this PN junction. I can replace by a resistor whenever I'm applying AC signal for AC signal analysis. So that's why we are doing DC analysis. Why I'm doing DC analysis? Like when we are doing a diode question, okay, then what I was doing, this was your diode, here was a DC supply, here was AC supply. So first I was doing DC analysis. I was finding what is ID, and when I'm using the AC signal, I was replacing this by a diode of 25 or 26 ohm. Do you remember? Okay. So similarly now, first I will do DC analysis and I will find the value of IE. Okay. So when I say do DC analysis mean find IE and RE. Once I know this IE, RE, then I can go for AC analysis. Okay. So let us now say this is my input current and this is coming my output current. Input current will be always base, output current will be always in the correct collector, or emitter current is output current. Either this way or this is the output current. Okay. Now this is the thing. First DC analysis you know how to do. Okay, we have done so many problems. And once you do DC analysis, you find IE, you know the RE. Once you know the RE, after finding RE, now how to solve for AC analysis, that we are going to discuss now. Okay. So I am rubbing this one. Can I rub this one? Karishma?
Yes, sir.
Okay. So now first DC analysis, find the IE, then find RE, and now I will do the AC analysis. Okay. Now what is AC analysis? AC analysis part. DC is as usual. Now AC analysis, what I'll do, I will make this diode short circuit. This diode will short circuit, this diode will become short circuit, this capacitor will become short circuit, and this will be grounded. Okay. And now once I ground this one, now how can I replace this transistor? I can replace this transistor like this. So we have transistor I have V input. This becomes short from here. Okay. You have a RB. Now this RB is connected to the base. RB is connected to the ground. So I can put RB like this. This is my RB. This is my simplified circuit. Now IE, here RE is not there. So this will be also grounded. Okay. And now this here, RC. This RC is connected to collector and ground. So I can simplify this one here. RC. And this is my as a collector. I am measuring the V naught. So this is my input, and here I am measuring the output. Okay. Here if I want, I can put a resistance also here. Now you know this IB characteristics is like this. That means at the output there is a very high resistance. This parallel line shows very high resistance. Okay? Transistor has a very high resistance. So if I want, I can put a output resistance here R0 in parallel with RC. So this is my equivalent circuit for AC analysis. This is the equivalent circuit. This is the equivalent circuit. Okay. Now I would replace this equivalent circuit means now this is a simplified circuit. It's not equivalent circuit. This is a simplified circuit. This is a simplified circuit. Simplified circuit. Now I want to replace transistor by equivalent circuit. Equivalent circuit. So what is equivalent circuit of transistor? You have to replace this. Now I naught current is flowing here. I input current is coming from to the base, and RC I naught current is flowing. And here this is the capacitor. This is the collector where IC current is flowing. Ammeter IE current is coming. Here IB current is flowing. So because I'm doing our AC analysis, so I will use a short notation IC, IE. I will use the short notations IE. Now for AC, this transistor is a resistor. Okay. So what I can do now, I can replace. Now I'm just replacing this transistor. How to replace this transistor? So this is my transistor. This is my transistor where IC current is flowing. Here IP current is flowing, and here IE current is flowing. Okay. This transistor I can replace by, say, IB current is flowing. I can replace this by a resistance RE. This is a resistance. This diode will be replaced by a resistor RE. Okay, and here this is my ground, and the top, this is the input part. This is the V input, and here top a current IC is coming. So this will be replaced a fixed current source. This IC will be replaced by beta IB. Beta IB. So this is basically my equivalent circuit of this transistor. So V input you're applying here. Okay. And a IC is coming here. IC is coming from here in the output. So IC basically, if you see the IV characteristics, so output characteristics means only fixed current. So a fixed current is flowing here, and this is the input resistance, the VI. So this is the equivalent circuit. Let me simplify it further. Now this circuit can be simplified further. Now how much current is flowing? Tell me. How much current is flowing in the RE? Tell me. How much current is flowing in the RE resistor?
IB plus beta IB.
Yes. Plus IB plus this beta IB. And I can take common IB. This is the beta plus 1. Okay. Beta is very high. So I can say this current is basically beta IB. Can I say like this? The current
Yes,
is beta
sir.
IB. beta
Yes,
IB,
sir.
which is IC, is negligible. And this circuit I can further simplify. I can say this is because current is coming IB and this is current beta IB. So I can replace this resistance now by beta RE. Is there anything changing now if I'm changing like this? If I say the resistance is not RE, it is beta RE, is that anything I'm modifying now? Now I want to make input and output separate. So IB is coming, here current is beta IB, and I want to separate this input. So I say the here current is beta, here current is IB only, but resistor is beta RE. So now this, by calling like this, I can separate it out my this one input, and my output is simple a current source, because in the transistor characteristics, it can be replaced only by a output current, because there is only output current inside, fixed output current in the output characteristics. So this is my equivalent circuit for transistor. Okay, so whenever you have a transistor like this, where IB is flowing, I is flowing, IC is coming, this transistor can be replaced by this equivalent model. By replacing this by our calculations become very simple. Now tomorrow I will discuss in detail with doing some example how to do AC analysis. Okay, so I'll stop here. Thank you. Tomorrow we'll discuss in detail. Just go through this one. Now if any question, please ask me. Here, Leo,
No question.
Karishma.
सर ये करंट जो है आरई में
हाँ।
वो आई 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 नहीं है।
आई है ना, आई क्या होता है, बीटा आई भी होता है।
यस सर।
तो मैंने क्या किया कि इसमें करंट क्या, इसमें वोल्टेज ड्रॉप कितना है, इसमें वोल्टेज ड्रॉप कितना है, बीटा आई बी इंटू आर ई, ये वोल्टेज ड्रॉप है।
यस सर।
बी, ये आई बी प्लस बीटा आई बी, ये बन गया बीटा प्लस 1 आई बी, दिस इज इक्वल बीटा आई बी। तो दिस इज द करंट एंड दिस इज द रजिस्टर, so this is the voltage. Okay, now I'm saying no, resistor is beta RE and current is IB. Still the voltage drop is same, yes or no?
यस सर।
That's what only I'm doing. Instead of this beta I'm multiplying here and I'm saying current is IB, because input current is IB, so I want to make this current also IB so that I can separate this input and output. Now IB is coming, IB is going here, voltage drop does not change. Okay, that is my input, and here input is what, input characteristic is what, input characteristic is this one, na? IC, IB, what is IB versus VB. So here you have VB equal to 0.7, which is not changing here. Okay, and here output characteristic, you have a fixed IC current. The fixed IC current is flowing. So this device can be replaced by this equivalent model, and this model is called RE model. So I am replacing transistor by a RE model. Okay, and now tomorrow we'll discuss why we are doing this one and how problems comes in the exam. Thank you.
Thank you, sir.